Okay, everybody, I'm hitting part two here on this practice set, doing some solutions for you guys. We're proving what type of quadrilateral is graphed, and can't just graph it and say what we think. We actually have to come up with some evidence that shows what type of quadrilateral this is. So we do this using coordinate geometry. And so let's put these points in here. I want you guys to carefully put these points in and label them. So A is at 1, -2. B is at 7, -5. C is at 4, -8. D, -2, -5. All right, let's get a straight edge. There we go. Actually, I might put point A out here. All right. And maybe I'll just... Okay, so here we are. So this looks like a parallelogram. It doesn't quite look like a rectangle or a rhombus. So let's start this by showing it's a parallelogram. So we think it's a parallelogram. It's our guess. So let's prove. I'm thinking parallelogram only. So not the more specific kinds such as rectangles and rhombuses. So how do we do that? So parallelogram has lots of properties. We could show the diagonals bisect. We could show that the opposite sides are congruent. And we could show the opposite sides are parallel. I want to do the opposite sides are parallel because that will give us a lot of information to show that it's not a rectangle. So how do we show sides are parallel? Well, we use slope. With slope. And what is slope? I'll zoom in on here. Slope is rise over run. So we could use the slope formula, which is y2 minus y1 over x2 minus x1. But I'm just going to count it for now, because it's already graphed. But let's be specific in labeling, in our labeling here. So let's say slope from D to A. And we're also going to find the opposite side, so slope from C to B. And then we're going to do the slope from A to B and the slope from D to C. And let's compare all four of these and see what we get. So D to A. So we're rising 3, running 3. So 3 over 3, that's 1. Now let's do C to B. We are rising 3, running 3. 3 over 3, which is 1. So we've now proved that segment DA is parallel to CB because slopes are congruent. Slopes are equal. Okay, let's try AB. So we're going from -2 to -5. So we're dropping 1, 2, 3. So we're going down 3, and then we're going from 1 to 7. So that's 6. -3 over 6. That simplifies to -1/2. And D to C, we're going down 1, 2, 3, and over 1, 2, 3, 4, 5, 6. down 3 over 6, that's negative 1/2. These two slopes are the same. So AB is parallel to segment DC. And the slopes are equal, as our reason. Okay, so that means we can put our congruent symbols on our figure. Not congruent, but parallel symbols. So far we've proven this is a parallelogram. Now, is this a rectangle? So, is rectangle? And the answer is no. Because if we look at the two adjacent sides, let's compare DA and AB. So DA has a slope of 1, and AB has a slope of negative 1/2. So DA is not perpendicular to AB, because what do the slopes have to be? They have to be negative and reciprocal, and they're not, because slopes are not negative and reciprocal. Okay, so this is not a 90-degree angle, so it can't be a rectangle. It means that also takes square out. Okay, so if something's not a rectangle, it's certainly not a square. But could this be still a rhombus? So how can we prove that? Now, a rhombus has all congruent sides. So we could do the distance formula on all four sides. I don't want to do that. So, well, we actually wouldn't have to do all four. We could just do, these two adjacent and just prove it, because they don't look congruent. But we can't just say it doesn't look congruent and that's our evidence. So I'm going to use some properties of diagonals here. I know that the diagonals of a rhombus are perpendicular. And we look at this, we can tell it's not perpendicular, but how do we prove perpendicular? These diagonals are not perpendicular, and that's by, again, using the slope. So let's find the slope of D to B and the slope of A to C, and we're going to compare them to see if they're negative reciprocal. Well, D to B is a horizontal line right here. Horizontal lines have no slope, zero slope. A to C, we're going down -2 to -8. So we're going down -6, and then we are running 1, 2, 3. So that's -2 slope. So the diagonals are not perpendicular. Therefore, A, B, C, D is just a plain old, is a parallelogram. Okay, a little bit of work for these, but that's what we got to do. So I proved it was a parallelogram with using the slopes. And I did everything with slope here. I proved that it's not a rectangle by comparing two adjacent sides that were negative reciprocal, and I also did the diagonals. The reason why I did all slopes with this, because if I did the midpoint for the diagonals, I would still have to do more slope calculations, and I figured out if I just calculate a bunch of slopes, it'll make this problem less work in the long run. Okay, let's try 20. Okay, so let's carefully graph this. A, B, C, -5, 4, or -5, -4. Hold up, let's back that up. -5, -4, negative 5, negative, negative 5, 6, negative 5, 6. All right. Let's get a ruler. Okay. So it's not a parallelogram, clearly. It looks like, could it be, see, let me just make sure I plotted my points correctly. Negative 5, negative 4, negative 5, 6, and what do I have here? Negative 1, 8. Okay. One, two, three, four. No, I didn't plot that right. This is 1, 2, 3, 4, 5 is over here. All right. So 5 is over here. So negative 5, negative 4 is here. That's C. Negative 5, 6 is here. And that's D. Okay. There we go. Now, this looks like, maybe it's a trapezoid. Maybe DA and CB are parallel. Maybe this is a kite. So how about, let's check the slopes here. I think this might be a kite. I think this is a kite. Let's check if this is a kite. So what do we do if it's a kite? A kite would have two pairs of congruent sides. So DAAB would have to be congruent, and D to C and B to C. So we could use the distance formula for this. If we wanted to do something maybe easier, we could analyze the diagonals. So the diagonals with the kite are perpendicular and only one set bisects. So we could do that. Let's do that, I guess. So let's check the slopes. Let's check the slopes of the diagonals. And the midpoints of the diagonals. And if we do those two things, that's going to be enough. So let's do the slope of D to B and the slope of C to A. So D to B, we're going down 1, 2, and then over 1, 2, 3, 4, 5, 6. So that's down 2 over 6. That's negative 1/3. C to A, we're going up. So I'm from negative 4 to 8. So that's 12. So I'm rising 12. And then I'm going from negative 5 to negative 1. So I'm running 4. Up 12 over 4. That's 3 over 1. So segment DB is perpendicular to segment CA because the slopes are a negative reciprocal. Reciprocal, period. Okay. So that's a 90. All right. Now let's check the midpoints. Now if their diagonals bisect each other, and they're perpendicular, it would be a rhombus. Okay, so it doesn't look like a rhombus to me, but that's what, we don't want to just leave it here and say we're done. Okay, this is not enough. So let's check the midpoint. So the midpoint of DB. So we're going to do x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, D and B, D and B, so 1 plus negative 5. Okay, just make sure, I'm on B and D, so 1 and negative 5, 4 and 6. Okay, 4 plus 6. Gotta really double check your coordinates here. I make these mistakes too, so take your time, double check, watch your signs, and make sure the answer makes sense when you get it. So I'm coming up with negative 2, 5 here. Negative 2, 5, okay, right there. So this is my midpoint. That's looking good. Let's find now our midpoint of AC. Now we're hoping it's not the same one in this case, because if it is, then we've just proven rhombus. So AC, negative 1 and negative 5 are my x's. Negative 1 plus a negative 5. Divide that by 2, and now we got to do our y's. So we're doing A and C. A, so we got 8, and we got negative 4. So we got 8 plus negative 4. So negative 1 plus negative 5 is negative 6 over 2. 8 plus negative 4 is 4 over 2. And I get negative 5, 2 for AC. Which, maybe at first glance, like, oh no, we got the same thing. But no, the x and y's are switched. So negative 5, 2 is here. That's not the midpoint. The diagonals, this diagonal is not being bisected. So we know that A, B, C, D is a kite. The diagonals are perpendicular and only one diagonal is bisected. Okay, very good. So, this is the general idea for these kinds of proofs. They require a little bit of work. I think I'm going to let you guys work on 21 and 25 on your own. Graph the points, make a plan for how you're going to prove a quadrilateral, and sometimes you have to disprove the quadrilateral because, proving parallelogram in this case wasn't enough. We also wanted to show that it wasn't a rectangle or a rhombus. Okay, I'm going to stop it there. I hope that helps. Check you guys later. Have a good one.